NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams. All these little dots are stars?
All these little dots are galaxies, some of which are bigger than our own.
The James Webb Space Telescope has shattered the silence of the cosmos, uncovering sights that were never meant for human eyes. But what it has seen is not just awe-inspiring, it's alarming. Ancient galaxies defying time, alien worlds cloaked in mystery, and now looming threats heading straight for Earth. NASA is on high alert, and the question everyone's asking is, are we prepared for what's coming? James Webb Telescope's thrilling discoveries. The James Webb Space Telescope has pushed humanity deeper into the unknown than ever before. Its discoveries are thrilling, terrifying, and transformative, shaking the foundation of what we thought we knew about the universe. With its enormous mirrors and unmatched technology, this space telescope has delivered revelations that defy imagination. In its first months, the billion-dollar machine turned its eyes to the edges of the observable universe, capturing the faint light of galaxies formed billions of years ago. These ancient galaxies, bathed in a red glow from the stretching of space itself, appear larger and brighter than scientists expected. Their strange, chaotic shapes challenge our understanding of how galaxies should look in the early universe. Some of these galactic giants contain more stars than modern galaxies, raising questions about how they grew so quickly after the Big Bang. Among these discoveries, the telescope detected stars in their final stages of life. Some of these stars, massive beyond comprehension, are swelling into fiery red giants as they burn the last of their fuel. Others, smaller but equally dramatic, are shedding their outer layers in luminous clouds of gas. These dying stars, teetering on the brink of explosion, are a haunting reminder of the universe's violent cycle of death and rebirth. The telescope captured breathtaking images of nebulae, where the remains of these stars create intricate clouds of color and light, serving as a canvas painted by cosmic destruction. Turning its focus to exoplanets, the advanced space probe has achieved the unimaginable, peering into the atmospheres of distant worlds. By analyzing light passing through these alien skies, the telescope identified traces of water vapor, methane, carbon dioxide, and other molecules essential for life. On one planet, clouds of silicates were detected, suggesting a bizarre world with skies that rain molten rock. Another planet, orbiting a dim red star, showed hints of liquid water, a potential cradle for alien life. These discoveries paint a picture of alien worlds that are both familiar and wildly different from Earth, expanding our understanding of what a planet can be. One world stands out among the rest, a planet in the habitable zone of its star. The telescope uncovered signs of an atmosphere rich in water vapor, with chemical fingerprints scientists struggle to explain. Mysterious fluctuations in its light suggest weather patterns or even unknown biological processes. This planet, now under intense scrutiny, could be the first solid evidence of a world capable of sustaining life as we know it. We humans are a rare existence on this tiny blue planet, drifting somewhere in the vastness of the cosmos. While we continue to advance in technology, we remain unable to compete with the sheer expanse of the universe. Our only hope to explore its wonders is through powerful telescopes that allow us to witness the unimaginable vastness beyond our reach. Using data from this technological marvel, Space Telescope, scientists discovered 6 planets in the Gliese 67 system, with 3 or 4 potentially habitable super-Earths. Super-Earths are rocky planets larger than Earth but smaller than gas giants. Gliese 667 in the habitable zone shows Earth-like conditions, making it a prime candidate. Perhaps the most astonishing search is not just the nature of the planets, but what they may hold. Signals that could indicate intelligent life have sparked speculation across the scientific community. One unexplained phenomenon involves objects that appear to move in coordinated ways, altering speed or direction in patterns unlike anything natural. Although scientists remain cautious, the tantalizing possibility of alien civilizations cannot be ignored. Another discovery involves complex chemical signatures in planetary atmospheres that defy natural explanations. These signatures, found on multiple worlds, could hint at industrial processes or biological activities. Scientists are meticulously analyzing the data, aware that any confirmation of extraterrestrial life would transform human history. Adding to the excitement, the telescope has unveiled the structures of some of the most mysterious star systems in our galaxy. Multi-star systems, where planets orbit two or more suns, have been observed in unprecedented detail. These systems, once thought too chaotic to support life, show remarkable stability, opening up new possibilities for habitable worlds. The telescope has also provided new insights into stellar nurseries, regions of space where stars are born. By peering through the dense clouds of dust that hide these regions from visible light, Webb has captured the formation of stars in exquisite detail. The process, which takes millions of years, is revealed in a series of snapshots that tell a story of gravity, gas, and light coming together to create new suns. As if these findings weren't dramatic enough, Webb has detected what appear to be artificial signals in the form of highly organized bursts of light. These flashes, originating from deep space, are being analyzed for patterns that could indicate communication. The idea that we might be intercepting messages from another civilization is both exhilarating and daunting. The search for alien civilizations is no longer confined to distant hopes. With this new technology, humanity may be on the verge of answering one of its oldest and most profound questions. Are we alone? If there are civilizations out there, their existence may not just reshape science, but redefine the very fabric of human understanding. Even without concrete proof of life, the ramifications of these findings are truly remarkable. The telescope has shown us that the universe is not just a collection of stars and planets, but a dynamic, ever-changing arena filled with possibilities. The search for life now feels less like a distant dream and more like a question of when, not if, we will find it. In this age of exploration, the instrument is not just a machine, it is humanity's beacon in the darkness. Its discoveries remind us of how small we are and how much is still out there, waiting to be found. For every question answered, dozens more arise, pulling us deeper into the unknown. What if the James Webb Telescope's thrilling discoveries aren't just revealing the wonders of the universe, but also the looming cosmic threats that could shape humanity's future? Cosmic threats and humanity's fight for survival. Humanity's quest to conquer space has left a troubling legacy: space pollution. Over the decades, thousands of satellites have been launched into orbit, transforming the once pristine void above our planet into a cluttered graveyard of debris. Defunct satellites, fragments from collisions, and discarded rocket parts now swarm in Earth's orbit, moving at deadly speeds. This growing menace threatens active satellites, crucial for communication, navigation, and weather monitoring. One collision could trigger a catastrophic chain reaction known as the Kessler syndrome, potentially rendering low Earth orbit unusable for generations. Amid this backdrop of man-made hazards, the cosmos presents far greater dangers. From asteroid impacts to devastating solar flares, Earth faces threats that could wipe out life in an instant. While we strive to protect our planet, the universe reminds us of its unpredictable and often destructive nature. Let's momentarily step outside our narrow perspectives and consider something much broader. Imagine this. You're caught up in the daily battles, competition, and races among yourself when suddenly a stellar object collides with our planet with such force that it wipes out everything, much like what happened to the dinosaurs millions of years ago. Asteroids, remnants from the solar system's formation, are among Earth's deadliest cosmic predators. These rocky fragments, ranging from small boulders to mountain-sized giants, hurtle through space at incredible speeds. Most reside in the asteroid belt between Mars and Jupiter, but some stray dangerously close to Earth. One such near-Earth asteroid, Bennu, has captured scientists' attention. Bennu, roughly the size of the Empire State Building, has a slim chance of impacting Earth in the 22nd century. Despite the low probability, the potential consequences of a collision are devastating. If Bennu were to strike, it would release energy equivalent to billions of tons of TNT, causing massive destruction and triggering global climate shifts. To better understand Bennu and its threat, NASA launched the OSIRIS-REx mission, which successfully collected samples from its surface. These samples are now being analyzed to learn more about their composition and trajectory, aiding efforts to predict and mitigate future asteroid threats. Another asteroid, Apophis, once caused widespread alarm when initial calculations suggested it might collide with Earth in 2029. While further observations ruled out an impact, Apophis will make a remarkably close approach, passing within 20,000 miles of Earth, closer than many satellites. This near miss provides scientists with a rare opportunity to study the asteroid up close, refining our understanding of near-Earth objects and enhancing our ability to defend against potential collisions. The political chaos in our hectic daily lives have consumed us to the point where we rarely stop to think about our true home, the Earth, and the looming threats surrounding it. How do we save it? We overlook the delicate balance of our environment and the growing threats it faces, whether from climate change, natural disasters, or cosmic dangers. In our race to achieve and survive, we neglect to acknowledge the fragile state of the planet that sustains us all. To combat the threat of asteroids, scientists are developing innovative solutions. One strategy involves deflecting an asteroid's path using kinetic impactors, a spacecraft designed to collide with the asteroid at high speeds, altering its trajectory. NASA's recent DART, Double Asteroid Redirection Test mission, successfully demonstrated this technique, marking a significant milestone in planetary defense. Another concept explores using gravity tractors, where a spacecraft's gravitational pull gradually shifts an asteroid's course. These efforts, though in their infancy, represent humanity's determination to shield Earth from cosmic catastrophes. While asteroids threaten from afar, our own sun poses dangers much closer to home. Solar flares and massive explosions on the sun's surface release intense bursts of radiation and charged particles. When aimed at Earth, these solar storms can wreak havoc on our planet's technology-dependent infrastructure. A powerful solar flare can disrupt radio communications, damage satellites, and overload power grids, leading to widespread blackouts. The 1989 geomagnetic storm, triggered by a solar flare, caused a major blackout in Quebec, Canada, leaving millions without power for days. In today's interconnected world, the consequences of a similar event would be far more severe, potentially disabling critical systems like air traffic control, banking networks, and emergency services. Moreover, solar storms can accelerate the deterioration of satellites in orbit, reducing their lifespan and increasing the risk of collisions in an already crowded space. Even astronauts aboard the International Space Station face heightened radiation exposure during solar flares, underscoring the pervasive risk posed by the sun's volatile nature. To prepare for these threats, scientists are investing in space weather forecasting. Satellites like NASA's Solar and Heliospheric Observatory monitor the sun for early signs of solar activity, providing valuable warnings to mitigate potential damage. Engineers are also working to harden electrical grids and satellite systems against the effects of solar storms, ensuring greater resilience in the face of the sun's fury. Among the most enigmatic threats to Earth are rogue planets, celestial bodies ejected from their home star systems, wandering the galaxy untethered. Unlike asteroids or solar flares, rogue planets are less likely to strike Earth directly due to the vastness of space. However, their potential to disrupt our solar system's delicate balance is profound. If a rogue planet were to pass close to our solar system, its immense gravitational pull could wreak havoc. It could dislodge asteroids from their orbits in the Kuiper Belt or Oort cloud, sending them hurtling toward Earth. Even a slight perturbation of planetary orbits could lead to catastrophic consequences, altering Earth's distance from the sun and triggering dramatic climate shifts. Despite their potential for destruction, rogue planets also ignite curiosity. These solitary worlds, often shrouded in darkness, may harbor conditions unlike anything seen in our solar system. Some rogue planets could retain heat from their formation or possess thick atmospheres insulating their surfaces, raising the tantalizing possibility of subsurface oceans or even microbial life. As telescopes like James Webb peer deeper into space, scientists hope to uncover more about these cosmic nomads, transforming fear into fascination. The threats posed by asteroids, solar flares, and rogue planets underscore the fragility of life on Earth, yet they also highlight humanity's resilience and ingenuity. From crafting deflection missions to advancing space weather forecasting, our efforts to defend against cosmic predators reflect a deep-seated determination to survive. In the face of these dangers, international collaboration is crucial. Space agencies around the world must work together, pooling resources and knowledge to create robust planetary defense systems. Public awareness and investment in space research are also vital. ensuring that humanity is prepared for whatever the universe may throw our way. As we continue to explore the cosmos, the dual nature of space becomes ever clearer, both a realm of wonder and a source of peril. While Earth may be a small, fragile world in an infinite universe, our ability to confront its cosmic predators demonstrates the power of human ingenuity. With each challenge overcome, we take another step towards securing our place among the stars. But these are threats that are so close to us. What if a black hole is quietly lurking at the center of our galaxy, ready to devour everything in its path, including time itself? Are we truly safe in the vastness of space? Black holes, the cosmic monsters lurking in the dark. We were all introduced to a captivating illustration of a black hole through the Interstellar movie, long before we saw its actual image. This powerful and utterly fascinating phenomenon captured our imagination, and our curiosity only intensified when the first real image of a black hole was finally unveiled. Black holes, the universe's ultimate enigma, continue to fascinate and terrify scientists. These cosmic giants are not just the stuff of science fiction, but a very real, albeit invisible, threat lurking in the vastness of space. Their power is immeasurable, capable of devouring everything in their vicinity, stars, light, and even entire galaxies, without leaving a trace behind. Once an object crosses the event horizon of a black hole, there is no escape, not even light, making them the ultimate cosmic predators. These invisible monsters feed on matter and energy, distorting space and time in ways that defy our understanding of the laws of physics. In 1915, Einstein's general theory of relativity redefined gravity, describing it as the curvature of space and time. This theory predicted black holes, objects with such extreme density that they warp space-time so intensely that even light cannot escape their gravitational pull, creating an ultimate gravitational object. The most terrifying feature of black holes is their ability to bend the very fabric of the universe. The gravitational pull of a black hole is so strong that it warps space-time around it, creating a region from which nothing can escape. Time itself slows down near the event horizon, and the closer something gets to the black hole, the more distorted the fabric of reality becomes. This eerie behavior is what makes black holes both fascinating and dangerous. In the depths of these celestial monsters, matter is crushed into an infinitely dense point known as a singularity, where our understanding of physics breaks down. One of the most mind-boggling aspects of black holes is their sheer size and their destructive capabilities. The Milky Way, our home galaxy, is home to an immense black hole that has earned the name Sagittarius A, pronounced Sagittarius A star. Located at the very center of the Milky Way, this supermassive black hole holds a mass equivalent to 4.3 million times that of our Sun. It is an unfathomable beast, stretching its gravity over vast distances and exerting its dominance over the entire galactic core. If you were to stand near Sagittarius A, the immense gravitational forces would stretch and compress you, a process known as spaghettification. No known force in the universe could stop its hunger for more, and yet this black hole, like many others, remains largely invisible to the naked eye. The only way scientists know it's there is by studying the behavior of nearby stars and matter being pulled toward it. What makes Sagittarius A even more frightening is that it is not a solitary predator. The center of many galaxies, including our own, is thought to harbor similar supermassive black holes, each one waiting to consume anything that ventures too close. These cosmic monsters can grow to monstrous sizes, with some black holes at the center of distant galaxies containing billions of solar masses. Their immense gravity pulls in gas and dust, forming a swirling disk of matter that heats up and shines with incredible brightness. This region, known as an accretion disk, is one of the most violent and energetic places in the universe. Beyond their size, black holes are shrouded in mystery. What lies inside them? Once something falls beyond the event horizon, it is lost to the universe forever. No information can escape from inside, making black holes the ultimate cosmic prisons. The singularity at their core is a place where the laws of physics break down and theories of quantum mechanics and general relativity collide. In essence, a black hole is a place where time and space lose all meaning, offering a glimpse into the deepest, darkest secrets of the universe. The discovery of gravitational waves, ripples in the fabric of space-time caused by the collision of two black holes, has opened a new chapter in our understanding of the universe. In 2015, scientists detected the first-ever gravitational wave from a black hole merger, confirming a key prediction of Einstein's theory of general relativity. This discovery provided a glimpse into the extreme forces at play in the universe and highlighted just how much we still have to learn about black holes. What if we could harness the power of black holes? Could we unlock the next step in human evolution? Or would it be our downfall? How and when do we achieve it? The answer is energy, advancing toward a higher civilization. Humanity's journey into space has been one of relentless advancement and discovery, yet we are only scratching the surface of what is possible. Over the past few decades, space technology has advanced at an unprecedented rate, from the launch of the first satellite, Sputnik, to landing rovers on Mars and sending probes to the outer reaches of the solar system. But as much as we have achieved, we are still a long way from mastering space and becoming a truly advanced civilization. This is where the Kardashev scale comes in, a measurement of a civilization's technological capability based on its energy consumption. The Kardashev scale, proposed by Russian astrophysicist Nikolai Kardashev in 1964, categorizes civilizations into three types. Type 1 civilizations can harness all the energy available on their home planet, from geothermal to solar and wind power. We currently are somewhere around 0.72 on this scale. Despite our technological feats, we still rely heavily on fossil fuels and have not yet fully utilized the potential of renewable energy sources or perfected sustainable energy. A true Type 1 civilization would be able to control the weather, manage planetary resources with precision, and harness all forms of energy in a sustainable way. The second stage, Type 2, represents a civilization that can harness the energy of its entire star, often conceptualized through the construction of a Dyson sphere, a hypothetical structure that could encapsulate a star and collect its energy. This level of advancement would allow civilizations to colonize other planets in their solar system, manipulate planetary atmospheres, and control cosmic energy. We are far from this stage, but advancements in space technology could bring us closer. Technologies like nuclear fusion, advanced space propulsion systems, and the construction of large-scale space infrastructure are all steps toward becoming a Type 2 civilization. Finally, a Type 3 civilization would be one that could control energy at a galactic scale, harnessing the energy of multiple stars or even black holes. Such a civilization would likely be capable of intergalactic travel, manipulating space-time, and potentially achieving immortality. We have no concept of how such a society would function, but it stands as an ultimate aspiration of technological advancement. Where do we currently stand on the Kardashev scale, and how do we improve? As mentioned, we are not even a full Type 1 civilization. To move up the scale, humanity must focus on improving our energy consumption and production methods. Achieving full energy utilization from renewable sources such as solar, wind, and geothermal power is a necessary first step. We must continue to innovate in energy storage technologies, allowing us to harness energy more efficiently. Further advancements in space technology will also be key. The continued development of space exploration, from the construction of permanent lunar bases to the colonization of Mars, will open up new frontiers for resource extraction and energy production. By mining asteroids for precious materials or using the moon for solar energy collection, humanity could gain access to vast new resources to fuel our growth. Space propulsion technologies, such as ion drives or nuclear fusion propulsion, will enable faster travel within our solar system, laying the foundation for interstellar missions. The frozen moon hiding a strange world. Triton is a unique world. Unlike most moons, it orbits Neptune in the opposite direction of the planet's rotation, suggesting it might be a captured object from the Kuiper Belt. Its surface reflects much of the sunlight that strikes it, giving it a bright, icy appearance. Beneath this reflective layer, though, lies a realm of possibilities. Ancient collisions, cryovolcanic eruptions, and perhaps even a hidden ocean. With the telescope's ability to analyze infrared light, researchers can map the moon's surface in unprecedented detail. Every molecule, every pocket of heat, and every shift in its thin atmosphere offers a clue to its strange past and dynamic present. Before we delve into this, it's clear that what lies beneath Triton's surface is far more extraordinary than anyone could have predicted. And this won't be the only revelation to leave you stunned. One of the telescope's strengths is its ability to analyze Triton's infrared spectrum. This technique works like a detective examining fingerprints, except these fingerprints belong to molecules. By studying the light bouncing off Triton, scientists can identify methane, nitrogen, and other compounds frozen on its surface. These icy materials might reveal evidence of past geological events, such as cryovolcanic activity, where cold, slushy materials erupted from the moon's interior. Such findings would suggest that Triton is not merely a frozen wasteland, but a geologically active world. The moon's atmosphere also holds significant interest. Composed mostly of nitrogen, it's incredibly thin and dynamic. When sunlight strikes the surface, some of the ice sublimates, turning directly from solid to gas, and rises into the atmosphere. This process creates a tenuous veil of activity that the telescope can observe. Tracking the movement of gases like methane or carbon monoxide could provide insight into subsurface processes, possibly hinting at warm, liquid reservoirs below the ice. The possibility of a hidden ocean beneath Triton's icy crust is one of the most tantalizing prospects. Neptune's gravitational pull might generate internal heat through tidal forces, keeping a subsurface ocean in a liquid state. Such an ocean could harbor the building blocks of life. Although the telescope cannot directly see beneath Triton's surface, it can identify heat anomalies or peculiar surface features that suggest the presence of liquid water. For example, a warm spot on the ice could indicate active plumes releasing heat and materials from below. But what could this hidden ocean mean for life? If it exists, it might interact with Triton's rocky core, creating a chemically rich environment similar to hydrothermal vents on Earth's ocean floor. These vents are teeming with life, despite the lack of sunlight. Triton's potential ocean might be a comparable haven for microbial organisms. The discovery of such a habitat would have profound implications for our understanding of life beyond Earth. The telescope's findings on Triton could also reshape our understanding of the solar system. Triton's unique characteristics offer clues about the Kuiper Belt, a distant region of icy bodies beyond Neptune. Understanding Triton's history might help scientists unravel how similar objects like Pluto formed and evolved. The moon's composition, geological activity, and potential subsurface ocean could serve as a template for studying other icy worlds in the solar system. Despite its capabilities, the telescope faces challenges in studying Triton. The moon's vast distance from Earth, approximately 2.8 billion miles, means that even the most advanced instruments struggle to capture fine details. Additionally, Triton's faint reflected light requires long observation times, limiting the telescope's ability to monitor rapid changes. Nevertheless, the telescope's observations are laying the groundwork for future missions. These missions could include orbiters or landers specifically designed to study Triton's surface, atmosphere, and interior. After uncovering hints of Triton's hidden layers, the idea of sending a mission there becomes even more exciting. Tools to explore a frozen world. Imagine a future mission sending a lander to Triton. Equipped with advanced tools, it could sample the surface ice, analyze its composition, and search for signs of past or present water. If plumes are detected, the lander might even collect material ejected from the moon's interior, providing direct evidence of its subsurface environment. Meanwhile, an orbiter could map the moon in high resolution, study its atmosphere in detail, and detect geological activity. Together, these missions would paint a comprehensive picture of Triton, transforming it from a distant curiosity into a well-understood world. The instruments aboard the telescope are particularly well-suited for Triton study. The near-infrared camera, NIR-CAM, operates in wavelengths that pierce through Triton's haze, capturing faint light reflected from its surface. By analyzing this light, scientists can identify specific molecules present and create a detailed map of the moon's composition. The near-infrared spectrograph, NIR-SPEC, breaks down light into its component wavelengths, revealing unique molecular fingerprints. This allows researchers to determine the abundance and temperature of materials across Triton's surface. The mid-infrared instrument, RIMI, complements these capabilities by operating at longer wavelengths. It can probe Triton's atmosphere and detect trace gases that might indicate ongoing geological processes. MIRI's ability to detect faint thermal radiation also provides insights into the moon's temperature and potential internal heat sources. These instruments together form a powerful toolkit for unraveling Triton's many layers. Exploring Triton is not without its challenges. The moon's distance from Earth makes any mission a formidable undertaking. Current propulsion technologies would require over a decade to reach Neptune's orbit. Additionally, the faint sunlight at this distance limits the use of solar power, necessitating alternative energy sources like nuclear power. However, the scientific rewards of studying Triton could outweigh these logistical hurdles. Balancing exploration with planetary protection is also crucial. If Triton harbors life, even in its simplest forms, contamination from Earth-based microbes could jeopardize its pristine environment. Future missions must take great care to ensure that their equipment is sterilized and that they do not disturb any potential ecosystems. This ethical responsibility underscores the importance of cautious and well-planned exploration. Triton's story is still unfolding, but the telescope has already opened a new chapter in our understanding of this strange moon. Its observations could reveal whether Triton's surface bears the scars of ancient impacts, cryovolcanic eruptions, or other dynamic processes. The data might also confirm the presence of a hidden ocean, a discovery that would reshape our view of habitable environments in the solar system. By studying Triton, scientists hope to answer broader questions about the origins and evolution of icy worlds. Was Triton always part of Neptune's system, or was it captured from the Kuiper Belt? How do its geological and atmospheric processes compare to other moons like Europa and Enceladus? These questions extend beyond Triton, offering insights into the broader mechanisms that shape our cosmic neighborhood. Triton's potential habitability also raises profound questions about life's existence elsewhere. If an ocean exists beneath its icy crust, and if it contains the right chemical ingredients, could life have taken root there? Discovering even microbial life on Triton would be one of the most significant scientific achievements in history, proving that Earth is not unique in hosting living organisms. The path to understand Triton is just beginning. The telescope's observations are providing a foundation for future exploration. But there is much more to learn. Whether through advanced telescopes, robotic missions, or eventually even human explorers, Triton holds the promise of unlocking new knowledge about our solar system and the possibilities of life beyond Earth. It is a cold, distant moon, but its potential warmth and activity make it a beacon for scientific discovery. Step by step, human efforts have reached deeper into space, building the knowledge and tools needed to uncover the wonders of distant places like Triton, from rockets to space stations. Space exploration is one of those things that humans just couldn't stop chasing ever since they looked up and wondered what those twinkling dots in the sky were. From basic stargazing to building telescopes that could zoom in on other planets, we've come a long way. Back in the days before electricity or modern science, people would track the stars and planets with tools no more complex than sticks and stones. These ancient observations became the foundation for what would eventually lead to our race to the heavens. Fast forward to the early 17th century, and things got a little more serious with the invention of the telescope. Suddenly, the universe seemed closer. Galileo pointed his telescope at Jupiter and noticed moons circling around it. He also saw the phases of Venus, proving that not everything revolved around Earth, a big deal back then. This was just the beginning of humans realizing that the cosmos was a lot more complex than they had ever imagined. By the early 20th century, space travel wasn't just an idea from science fiction. A handful of scientists like Konstantin Tsiolkovsky in Russia and Robert Goddard in the United States started figuring out how rockets could actually work. Tsiolkovsky imagined rockets using liquid fuel instead of gunpowder, and Goddard made it happen. In 1926, Goddard launched the first liquid-fueled rocket, a small but groundbreaking step toward getting humans off this planet. The mid-20th century brought the space race, a heated rivalry between the United States and the Soviet Union. In 1957, the Soviets launched Sputnik 1, a shiny metal ball that became the first artificial satellite to orbit Earth. This shocked the world and gave the Soviets a massive lead in space exploration. The United States, feeling the pressure, quickly established NASA in 1958, setting the stage for a high-stakes competition to dominate the cosmos. Then came the 60s, and things moved at lightning speed. In 1961, Yuri Gagarin made history as the first human to orbit Earth, riding aboard Vostok 1. Not long after, Alan Shepard became the first American in space, though his flight was just a quick up-and-down trip. Inspired by these achievements, President John F. Kennedy laid out a bold goal: get an American on the moon and bring them back safely before the decade was over. This wasn't just about exploration, it was about proving who was the top player on the global stage. NASA's Apollo program took on this challenge with determination. After several test missions, Apollo 11 touched down on the moon in July 1969. Neil Armstrong and Buzz Aldrin became the first humans to walk on another world, leaving footprints that would become symbols of human achievement. Michael Collins, the third astronaut, stayed in orbit around the moon, waiting for their safe return. Armstrong's words, "That's one small step for man, one giant leap for mankind," captured the significance of the moment. The moon missions didn't stop there. Between 1969 and 1972, NASA sent 5 more crews to the lunar surface, collecting rocks and conducting experiments that revealed new insights about the moon's history. Apollo 17, the final mission, wrapped up this incredible chapter, leaving behind a legacy of ambition and ingenuity. In the 70s, space exploration shifted gears, focusing on living and working in space for longer periods. The Soviet Union launched a series of space stations called Salyut, with Salyut 1 debuting in 1971. These stations showed that humans could survive and work in space for weeks, even months. Over in the United States, NASA launched Skylab in 1973, conducting experiments in microgravity and studying the sun like never before. The 80s brought something new: reusable spacecraft. NASA's Space Shuttle program took off with the launch of Columbia in 1981. The shuttle wasn't just about getting to space, it was about making space travel more routine. These vehicles deployed satellites, repaired equipment, and played a key role in building the International Space Station, ISS. But the program wasn't without its tragedies. The Challenger explosion in 1986 and the Columbia disaster in 2003 served as harsh reminders of the risks involved. Despite these setbacks, international collaboration became a defining feature of space exploration. The ISS, which has been orbiting Earth since 2000, represents a partnership between NASA, Russia's Roscosmos, and agencies from Europe, Japan, and Canada. It's more than a space station. It's a floating laboratory where scientists conduct experiments that can't be done anywhere else. The ISS also symbolizes what's possible when countries work together, even during times of political tension. Meanwhile, robots have been doing their share of exploration, traveling to places humans can't yet go. NASA's Voyager probes, launched in 1977, ventured to the outer planets and beyond. These spacecraft are now sending back data from interstellar space, giving us a glimpse of what lies outside our solar system. Mars has been another major focus, with rovers like Spirit, Opportunity, Curiosity, and Perseverance crawling across its surface to search for signs of life. In the 21st century, private companies entered the space game, bringing new energy and innovation. SpaceX, founded by Elon Musk, became a leader in commercial spaceflight. In 2008, its Falcon 1 rocket became the first privately developed rocket to reach orbit. SpaceX followed this with the Falcon 9 and the Dragon spacecraft, which now transports supplies and astronauts to the ISS. In 2020, the Crew Dragon mission marked the first time a commercial spacecraft carried humans into orbit. Other companies like Blue Origin and Virgin Galactic are also making waves, focusing on suborbital flights and even space tourism. This shift toward privatization is changing the landscape of space exploration, making it less about government programs and more about commercial opportunities. With billionaires funding these ventures, the future of space travel is starting to look a lot more accessible, at least for those who can afford the hefty price tags. Looking ahead, the focus is back on the moon and beyond. NASA's Artemis program aims to land astronauts on the moon again, this time to establish a long-term presence. The program promises to send the first woman and the next man to the lunar surface, paving the way for eventual missions to Mars. This isn't just about exploration, it's about building the technology and skills needed to survive on other planets. International collaboration remains crucial, with Europe, China, and other countries contributing to ambitious projects. China, for example, has been making impressive strides with its space program, from crewed missions to the Tiangong space station to lunar exploration with the Chang'e missions. These efforts show that space exploration is no longer dominated by just a few players. It's a global endeavor. From dark matter to distant galaxies, every new discovery brings us closer to understanding the universe and finding what connects everything we see around us. Unseen forces shaping the cosmos. The universe is an enormous, mind-boggling place, filled with more questions than answers. One of the biggest questions is dark matter, a strange substance that doesn't shine, absorb, or reflect light. It's like an invisible thread holding galaxies together, yet we can only guess what it is. Scientists have suggested particles like WIMPs or axions might be the culprits, but nobody's nailed it down. Figuring out dark matter is vital because it shapes how galaxies form and move across the cosmos. Then there's dark energy, which is even weirder. It's believed to make up over 2/3 of everything in the universe, and it's pushing galaxies farther apart. Imagine a force so powerful that it's expanding space itself. Some say it's just a property of space, while others think it could be something entirely new. Whatever it is, dark energy holds the key to understanding whether the universe will keep growing forever or collapse back in on itself. The origin of the universe is another mind-bender. The Big Bang Theory explains how the universe started as an incredibly hot and dense point. But what caused the Big Bang? And was there anything before it? Some theories, like cosmic inflation, suggest the universe expanded faster than the speed of light right after it began, smoothing out everything we see today. But the details of how and why this happened remain a cosmic problem. Black holes are like the universe's ultimate vacuum cleaners, sucking in everything, even light. We know they exist, but the questions they raise are staggering. For example, what happens to information that falls into a black hole? This information paradox has physicists scratching their heads because it clashes with how quantum mechanics says the universe should work. Solving this could bring us closer to a unified theory of everything. Galaxies come in all shapes and sizes, but how did they get that way? Observations show massive variations, and some galaxies from the early universe seem way more developed than they should be. It's not just dark matter, but also the influence of black holes at their centers that shape these cosmic structures. Understanding this could rewrite the textbooks on galaxy formation. And don't even get started on the vast voids between galaxy clusters. These empty spaces might reveal how dark energy behaves on a massive scale. The hunt for life beyond Earth is one of the most exciting areas of exploration. Thousands of exoplanets have been discovered, and some could potentially host life. But finding biosignatures, like specific gases in an atmosphere, is no small feat. New tools like the James Webb Space Telescope are trying to solve this. But for now, it's a waiting game. What if life exists on a distant planet, just waiting for us to find it? Meanwhile, neutrinos, tiny particles zipping through the universe, are another problem. They barely interact with matter, but they're everywhere. Scientists are still trying to measure their exact properties and figure out what role they play in the grand cosmic design. The more we learn about them, the more they might reshape our understanding of physics. Then there's the multiverse idea, the thought that our universe is just one of many. If true, these universes might have entirely different laws of physics. While it sounds like science fiction, some theories in quantum mechanics and cosmology suggest it could be real. Proving or disproving this idea could completely change how we see reality. Time itself is another big question. Did it begin with the Big Bang, or has it always existed in some form? Time is more than a philosophical idea. It's central to how we understand the universe's origin and fate. Unraveling time's questions could open doors to understanding everything from black holes to the Big Bang. One of the greatest challenges in science is combining the rules of general relativity, which explain gravity, with quantum mechanics, which governs the tiniest particles. These two systems don't play nice together, especially in extreme conditions like inside black holes. Developing a theory of quantum gravity could bridge this gap and explain the universe's most extreme events. Cosmic rays, high-energy particles that slam into Earth, add another layer of uncertainty. Some come from known sources like the Sun, but others, especially the most energetic ones, have unknown origins. Cracking this code could reveal the most extreme processes in the universe, from exploding stars to active black holes. The imbalance of matter and antimatter in the universe is another perplexing issue. The Big Bang should have created equal amounts of both, but for some reason, matter won out. Understanding why could lead to discoveries that go beyond our current physics. Even the universe's expansion rate, measured as the Hubble constant, is a topic of heated debate. Different methods of measurement give slightly different results, creating a tension that hints at something missing in our understanding. Is it a problem with our measurements or a sign of new physics? The first stars and galaxies, forming in an era known as the Cosmic Dawn, hold clues about how the universe lit up after the Big Bang. Observing this distant era is tough, but upcoming missions aim to shed light on these early structures. Understanding this era is key to piecing together the universe's history. The universe is bursting with questions, from the smallest particles to the largest structures. Each discovery peels back another layer, revealing how much we still don't know. Understanding these cosmic riddles isn't just about curiosity, it's about defining our place in the cosmos. Is NASA hiding the truth about Triton's strange glow? Or is this evidence of something they don't want us to know? Tell us your thoughts and remember to like and subscribe for more.